Welcome to NSF's Europe's Future in Space, here in our 7th episode of our series covering all about the European space industry. You know, after 6 episodes, you probably already know the deal. We bring folks from that industry and we have a chat and get to know them better. And so far, the feedback we've been having, it's really great. I've seen a lot of people that have liked this series. So, without further ado, let's talk about Europe's future in space here on NSF.
And here we go.
We have liftoff.
Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, roger, Atlantis.
Water towers fly! Yes! Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange!
Oh my god! Oh my god!
Décollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane would be igniting in the flare, correct?
Yikes. You read? Sure. We don't need any more of these.
That's right. Welcome back to NSF Live here on Europe's Future in Space, our 7th episode so far. It's kind of crazy that we're already on episode 7, but we've got for the first time in already this show, we have a space logistics company, which is quite interesting. We're having D-Orbit here on our show with Stefano Antonetti, Vice President of Business Development at D-Orbit. Thank you for being here with us.
Thank you for having me.
And, for the moment, you guys kind of seem to be more on the side of space delivery, but we'll talk about all of the, interesting stuff that sort of goes more about the logistics in space, which I've read about that, and it's really interesting. We'll talk about that. But of course, as well, we're going to have you, our viewers, here, right? You can tag at NASASpaceflight in chat and have your questions answered. We're going to have them here on our queue. And who's going to do that here with D-Orbit? It's going to be D-Wise coming from the Norwegian trip, I guess, here back to the show. Thank you, D.
Of course.
And also in the background, we're going to have Jay Keegan producing the show. Of course, he's always being sort of the person that it's also being arranging these interviews. So thank you as well for that, Jay. And without further ado, Stefano, there's one thing that I always ask, which is like, give me an elevator pitch of what D-Orbit does, because I said it's a space logistics, still in the delivery phase, right? But working onto the full logistics side of things. What does D-Orbit do, and what's sort of the origin of the company?
Right. So the company is now 14 years old. We began in 2011 in Italy. And we are a space logistics company, which basically, we want to copy what happens on Earth, right? Any business on Earth can actually be productive without logistic infrastructure. So we are trying to replicate such logistic infrastructures on space. So we started by debris mitigation. That's where our name comes from. Because after all, if you think about that, waste management is a logistic problem on Earth. So we said, okay, debris in space is a big deal. Let's start from that, because you want to build a logistic infrastructure step by step. Each step must be profitable in order to move on the next step. So so we started doing that. And then what happened, that space debris, although it's an urgency, it's not still a big market. So we decided to go definitely on the next step of logistics, which is last mile transportation in LEO orbit. And then, we'll try to cover everything else of the logistics. So tagging spacecraft or internet in space, cloud computing. So anything that can help anyone to succeed in space. There are now so many businesses that are starting to happen in space, thanks to the space environment. And the best way to leverage in this expansion of space economy is to provide them services. So yeah, you see here in the pictures, this is our Ion carrier. So it's basically a space carrier, an orbital transfer vehicle. It's the most flown in the world. We launched 17 missions since 2020. We delivered more than 180 payloads, and we are trying to copy a little bit the model of airlines. So to launch in a regular, repetitive way, and really base it as a service. And we've seen that having a good, reaction from the market. Still a lot of work to do, because of course, as you know, space market isn't that mature after all. So that's, I hope this will increase to the success of the community, because like if you work in space, it's because you are a space enthusiast or space passionate, so you want to see everyone succeed in space.
Yeah, one of the things that I really find interesting about the Ion spacecraft is, you guys have launched so far, I think 17 of them, and how many of them are still in orbit? Like, because I think some of them stay there for a while, right?
Yeah, I think there are 14 right now. I think the 3 re-enter after a while. We are very careful to the re-enter phase. We have a lot of fuel, and we carefully plan our re-enter. Definitely, we don't want to generate additional waste in space. So yeah, I think 3 re-enter so far since 2020.
Yeah, it's one of those things that I find really interesting, that you guys sometimes also hold onto some of these customer satellites as well and deploy them when it's convenient and things like that. Like I find that kind of service as well really interesting, precisely because, as you mentioned, right, that you have that constant flow of delivery into space, but sometimes you not always need it immediately. You just need it when it's precisely needed, right? Like it's not all the time, and but you have it there and you can deploy it at any time, which I think is quite an interesting way of that spacecraft to be able to operate as well. We've seen
Yeah, you're
recently,
right.
yeah, recently we've had other contracts as well going out for that. So you started launching in 2020, you just mentioned, right? What was the development of the spacecraft? Like, you went from originally trying to get the orbiting services and things like that, but then you said you pivoted to the Ion spacecraft. Like, how was that development process?
So at the beginning, so we spent the first 4 years of the company, basically to 5 years, to develop what we call decommissioning devices. So we thought, okay, space abuse is a problem, and usually good sense says that if you don't know how to solve a problem, at least stop causing it. So we said that it would be a big market if you had on board a spacecraft this decommissioning device that in our case was small independent intelligent motors, that when the satellite fails or idles, this motor would take over the satellite and basically deorbiting it in a proper way. We thought that regulations in that sense would be much faster, and that was not the case. So we actually demonstrate one of those devices in orbit. Our mission was our first deorbiting mission was in 2017. We launched a small satellite called DSAT, and this satellite deorbited. Like we failed the satellite to die. It was most satellites were CubeSat. We faked the satellite to die, and then this small motor inside the satellite took over the satellite, the control and everything, and deorbited the satellite. And then again, when we tried to market that product, the market wasn't that reactive. So we said, okay, let's go do the next step. And we knew the next step would be transportation. Why transportation? Because, like the final step, or like the final big step, would be in orbit servicing. So being able actually to attach, to dock to another satellite and tagging it, doing maneuver, removing it, relocating it. But in order to do that, you first need to learn how to make satellites that have a lot of delta V, a lot of capabilities, a lot of agility. And so the logical intermediate step in order to achieve that, and at the same time being profitable and to open a market was doing space transportation. And we have identified a niche in the market, which was last mile space transportation, because SpaceX was coming and there were starting to be a lot of rideshare launches. And so we knew there would be a lot of low-cost launches, but in very specific place in outer space. And those satellites, especially if were CubeSat, a small satellite, would have needed a lot of propulsion to go where they needed to go. So we said, okay, let's take advantage of it and actually provide those satellites with a last mile delivery service. And it was a good idea. The success was almost immediate. And we developed several versions of this carrier, which we called ION, which is the acronyms of In Orbit Now. It doesn't have electric propulsion, doesn't have ion propulsion. It's got chemical. Yeah, that's the question. We are not. Sometimes we're not very good at names, the engineers. Like we need somebody else to craft names because engineers are not that good at it. But okay, so we decided to go in that direction. So yeah, I mean, 70 launches so far. We're pretty proud of it, and it's not easy also to do such a thing in Europe sometimes.
Yeah. And there's also this thing about, the spacecraft names as well. Because, well, you mentioned about, engineers were not, but these tugs, this spacecraft, I call them tugs, but it's actually more than that. It's a spacecraft, right? In their own sense. But they also have very funky names. Like I think it's really interesting. I don't know, Jay, if we can show the graphic with all of the names. It's really interesting. There's one of them. There we go. Thank you, Jay. Like Thrilling Thomas, Glorious Gradia, and things like that. It's really interesting. It's sort of reminiscent of like other companies also having funny names and everything. I really like it. That you have fun a little bit with these names. Do they have any meaning or something?
Yeah, absolutely. So like ION is the name of the spacecraft. SCV it means space carrier vessel. So we take inspiration from how actually naval vessels are named us. So we have several classes of spacecraft. This is a space carrier. And then the names are just names of employees. We draw in a big box every launch, and then we transform that in Latin, because just like we are Italian, so we need to put some Latin language somewhere, and we put an adjective in front. So I think it's very nice. It's very nice to have your name in space. My ION has already been drawn, so I'll be, I think, a CV22, I guess. I'm not even sure. So it's it's nice to have your own name in space, your own spacecraft in space. I think again, most of the space industry is nice. I like it because most of the people that work in space, it's because they are passionate of it. So I think it's a little bit everyone's dream to have your own spacecraft in space, especially like a kid's dream. So I think it was a very good idea. We are pretty proud of it.
Yeah, and I believe also so each of these spacecraft, when they launch, it's also part of a mission. It's true that they're usually on transport missions and things like that, but like the spacecraft mission also has a name, right?
Exactly.
We can see there, Wish Upon a Star, Endless Sky, Ascend. Like that's really interesting as well. You were saying about the naming and everything, but I do find these names quite really interesting to me at the very least.
Yeah, I think it's interesting. It's when you do a space mission, it's a little bit your baby, so you need to give a name because it has its own story, basically. From the conceiving, and then you can start to fill up with the customers, you identify the launch opportunity, launch into space, you bring it to the launch base. So really, it's like a big baby that has its own history. It grows with you. Although it doesn't take much actually to build an ION to launch it to space, basically it takes a few months, but still, it develops a little bit. So we are very proud of our babies, and they will their path to the stars.
Yeah. I wanted to talk about, because we're seeing here a bunch of them have been launched, or pretty much almost all of them have been launched on Falcon 9 on transporter missions, and yeah, there we go. I've seen though a couple of them I think launch on Starlink missions. I actually first knew about the Orbit because they launch on a Starlink mission, and I was writing about that Starlink mission, and I actually approached the Orbit precisely to know a little bit more about the Ion spacecraft and everything, and write about it for the article. That was really nice. I think it was. It's SCV-9, I think it was, on a Starlink mission. But yeah, it was really interesting to see that, you guys have been using that opportunity of, really regular rides to space. But you recently had a contract, PLD Space announced that you guys had booked a ride on Mura 5 as well. So how does that work? Like, how do you guys approach a company? You're like, we want to launch on your rocket, right? Like, how does that work?
Pretty much like that. I mean, so far we launched mostly on Falcon 9. We had the first launch was done in Vega, and we are of course diversifying launches is super important. So like for instance, PLD the Mura is specialized on equatorial launches, which is something that a Falcon 9 doesn't do that much, and also, diversifying is important because it's important to give customers different options because they may prefer, for any reason, one launcher respect to the other, even if there's a difference of price. For instance, a European customer may prefer to go with European launchers because they got money from European institutions. So in order, to show some geo return, as we call it, and they prefer to launch a European launcher. So yes. We are basically in contact with most of the commercially available launchers. We were talking with PLD since a long time, and we finally signed this agreement for equatorial launches, and that makes a lot of sense. PLD is a very nice company. Doing launchers is very hard. It's a very hard business. And it's not obvious, really. I mean, we've been following them since the beginning. And again, also being Europe, where it's not that easy as elsewhere to raise large capitals. And also the failure culture is less, spread, maybe compared to the US. So failure sometimes is not an option in any case, because it's not really well seen from investors, even from customers. So they've been doing very well, and we are very proud to have been able to sign this agreement with them.
Yeah, I really like the idea of, if you have a delivery company, like say UPS or something like that, right? Like a delivery company, you use whatever available airplanes there are, right? Like you just use whatever is there, and I guess that sort of mindset can be applied as well to space. I want to talk precisely about the delivery, because just like with planes, they are short flights, there are long haul flights and everything, and so cargo can also go on long haul flights or short flights and everything. Space is also similarly oriented in that way, where you can go to LEO, you can go to GTO, right? Like those sorts of different orbits. Like, is the Ion spacecraft also capable of moving to different orbits, deploying? How does that work?
Yes. So as a base, Ion, we have we have several offers on Ion. So we can change the true anomaly, and we can change the altitude. There are these two maneuvers that have been asked so much by our customers. So usually, for instance, SpaceX launches, they go on SSO, and they are around 500 kilometers, but some customer needs to go a little bit below, a little bit higher. So we can definitely put them on different altitudes. Usually are between our change of altitudes plus minus 100 and 150 kilometers. What we do, it's not much, but we can go much farther. We can go even up to 1,200 kilometers. It was one of the missions that will go that far. Then we can change the true anomaly, the Alton, and this is something also it's been asked quite a lot by our customer. That takes a little bit longer because you have to drift along the orbit, so it takes a little bit longer. So this is what we are able to do right now, but we are developing a family of tugs that are able to do different kind of maneuver and to serve a different kind of orbital regime. So we're already developing our Mark III of Ion. So Ion actually now it's got already the second generation. We are working now with the Ion Mark II, and now we're developing the Ion Mark III, which will be capable of a wider range of orbits. And we are looking also to GEO to be able to deploy smaller payloads to GEO. And at the same time, we are developing a larger tug, much larger, which is like almost 10 times larger than Ion, which is supposed to deliver in-orbit services like life extension or relocation of assets. And at the same time, it can deliver payloads on orbits like from GTO to GEO or even in lunar orbit. So we are trying more or less step by step to develop this family of tugs that is able to, or carriers that are able to basically cover most of the environment between the Earth and the Moon, and then potentially beyond afterwards. This is our GEA platform. We are very proud of it. We just we signed last year a large contract, under 20 million contract with the European Space Agency. It's the largest contract in Europe for this kind of commercial missions. And this activity is to develop the GEA platform, which is a platform which is thought to be a real tug. So to capture and to dock with another spacecraft in geostationary orbit and to provide a number of services, but also to transfer payloads from GTO to GEO or to lunar orbit.
Yeah, that sounds really cool because, there's been a lot of talk recently precisely about robotic, as we're seeing here, robotic servicing, but also moving around and everything to not waste, so to speak, some of the propellant, or like if it's low in propellant, you can give it a life extension, as you mentioned as well. That's really important as well to maximize the utilization of all of these space hardware. One of the other things as well, can you talk about any other sort of capabilities of the Ion spacecraft that we may have not mentioned here? Like,
yes,
I don't know, maybe moving into other types of orbit, because the whole reason I ask you about that is, with PLD space equatorial launches, it kind of sounded to me like, oh, are you trying to go to GTO from there or something like that, right?
Yes, exactly. So again, the third version of Ion Mark III, we're definitely looking for GTO to moon orbit, which is something we're looking at. It's not, I mean, we don't think it's a big market per se, to be honest, the commercial market, but there's a lot, that's actually definitely an institutional demand for it. And we definitely are in good position to position ourselves to deliver that service. And so, yeah, that would come by the end of 2026. We don't have any lunar mission planned so far, but the capability will be there. And yes, so yeah, this is the Mark II of Ion. As you can see, it's has got on top this like of deployers. You can see also on the top left, you can see a small camera, because another service they also do, I didn't mention before. And actually, it's about half of our revenues. It's hosting payload and doing experiments. So usually, the deployment mission of satellites takes 3, 4, 5, 6 months, depending on the customer needs. But during and after, we usually carry a lot of experiment in orbit demonstration, orbit validations, or hosted payload that we operate for the customers. And this is very important because, reaching the so-called TRL9, so reaching the maturity or product, is really super important in space in order to demonstrate that your product is viable and sellable. And so there's not many opportunities for people, for developers, for space industry to test in a quick, affordable, and repetitive way the experiment in space. We are one of those platforms that can do that. And we have a pretty big and increasing demand for this kind of services. The other things also that we are starting to do, it's going a little bit slower, but we start to see many customers interested in, is basically to have, like to run the payload as an operational mission. So instead of building their own satellites, their own CubeSat, they just give us the instrument, we put in the payload bay, and we run it using the resources of the carrier. So using the telecommunication system, the power and everything of the carrier. And that, of course, is a big advantage for the customer because, yes, you lose a little bit of flexibility because you don't have your own spacecraft. On the other side, you don't have to actually spend a lot of money to build and develop your own spacecraft. So it's a sort of trade-off that some customer have appreciated and starting to come on board.
Yeah, I really find interesting that you don't have to always build the entirety of the satellite, right? Like just slap a payload on an Ion spacecraft and then you can at least test it and have it in space. So you mentioned with trying to get it to an operative status as well. We're gonna be going now to questions. There's a few things that I've seen already in chat. Do we have anything there? Because I've already seen a few of these questions.
Yeah, we sure do. So to start off, there's a question from Moldy Space Industry wondering, as the size of launch vehicles continues to grow with the likes of New Glenn coming online and of course Starship, are there any plans, things we can look forward to potentially regarding like larger space tugs in the future?
That's a very good question. We are monitoring very carefully the evolution of the launchers market because it's not easy to predict in the sense that there are many new ventures about launchers, and they're all doing a great job, but the road to success and to repetitivity and to competitiveness it's long. So of course with New Glenn and Starship, things can change a lot, and so yes, we are definitely developing larger. We are going for a larger size of our tug. So the third generation Ion will be almost double than the current one, a little bit smaller than the double. And the space tug for GEO Gaia would be above 2 tons spacecraft, so much larger. So yes, definitely, we are betting that the launch cost will decrease in the future because it looks like it's the general trend. And also in order to diversify us from the micro launchers market, we prefer to grow in size and also to provide additional services. So being able to carry larger hosted payloads or to make more complicated missions, or potentially, as Alex said, being able to go to the moon or Mars.
Awesome. And then we had a couple more questions about how you're working to differentiate yourself in the industry as all these players are coming online right now.
Well, it looks maybe trivial, but we try to differentiate ourselves through reliability. We want to be regular, reliable. We want to have a good reputation. We want our customer just to, we may not be now we are well positioned, but maybe in the future, we may not be still the best performance or the best price or whatever, but still we want to be super reliable. We want that customers, when come to us, they got a good service, they're happy what they got, that they put us in space, and we're really focusing a lot on that. We're really putting a lot of effort. I'm not sure that this would be something completely differentiating by the other competitors, but definitely we put a lot of attention on that. And then, of course, to give a competitive offer. So we look really carefully to the commercial market, which is not easy because commercial market is very uncertain right now in the space commercial market. While you go the institutional market, the defense market are more, let's say, there. But it's a very peculiar market. So to have an offer that can capture both quite efficiently is not easy. But we definitely, we are all department in the orbit, a small department what they do from every day is like to study the market, define trends, and see how this could be applied to our next generation of services and spacecraft.
Absolutely. Thank you so much. A reminder to everyone watching, tag at NASASpaceflight in chat, and I will potentially bring those questions in here. And with that, I'll hand it back over to Alex.
Yeah, I have more questions for you, Stefano, because there's a few things, because we were talking about the Ion spacecraft and how it's mainly about the delivery, the hosting a spacecraft or payloads, excuse me, the other way around, right? Hosting payloads, delivering payloads, and in the future, servicing other satellites and things like that with sort of the evolutions, right? But there was a certain mission. I think it was Starfish Space. There we go. I had to write it down because there are so many stars in the spaceflight industry, right? Starfish Space with the other spacecraft, and how that was really interesting because if I'm not mistaken, it was not originally meant to have a rendezvous where the Ion spacecraft was actually the one, getting close. I believe it was what happened there. Can you talk about what happened there? Because I remember writing about that and everything. But best if it comes from you, of course.
Yeah, I mean that was absolutely a super interesting mission. So yeah, with our partners of Starfish, we basically decide to simulate to test a rendezvous, not close approach, but far approach. And yeah, basically we, like two friends, we decide to take an appointment. Okay, so if you can find yourself in that position, I'll come close and take a picture of you. And so that's what we did, and that was an incredible mission because we both could. Both company could test some of their capabilities. So for us, it was like basically a rendezvous with a virtual object. So we were at the right place at the right moment. And they could do an incredible job to come towards us and being able to take a picture for not that far, actually. So that was a very incredible mission. Also because we didn't touch anything on it was just a standard regular Ion spacecraft, and we were pretty happy about the performances of that. Who knows about space knows that it's not so trivial to do this kind of mission, and that was quite incredible on our side.
Yeah, that was one of the things that I was sort of when I wrote about this was one of the things that it's just that it's another Ion spacecraft, and now you've got it. It's true that it didn't come super close, right? It was a far approach, but it was still an approach, and it's not rather easy to do in space. Did that help you guys to get to the future, refueling and servicing spacecraft? Like, did that help in any way to that development?
Yes, it does. Actually, one of the nice things to launch regularly a lot of spacecraft is that towards the end of life, the spacecraft, we tried a lot of things. So really, I mean, like now the mission is over, the spacecraft is healthy, so we try a lot of things. We try new devices that we have on board, new subsystems that maybe sometimes we don't use it during the operational life because it might be too risky, they may fail. And when we are towards the end of life, we test them. We test maneuvers. We test, like different operational profiles. And in only 4 years with our 17 mission, we really learned a lot about the operations. And definitely we'll be transferring this knowledge to our larger space tug, like the GEA, that will do life extension in GEO, and that's why we feel confident that we'll succeed, because we know that we've been trying a lot, we'll be doing a lot of mistakes, which is the best way to learn. So we are pretty confident that would go good. To be honest, like in the Starship mission, the Starfish mission, Starfish did most of the job. We need to be clear here. they definitely did most of the job, and so they show incredible capabilities, really remarkable capabilities in doing approaching maneuvers.
Yeah, I actually was wondering, because once you get all of these data from the different missions and everything, what do you see the long-term prospect of all of these missions? Like, do you see just having one single spacecraft that can do everything else, or are you going to be focusing eventually on having like different spacecraft in one for each purpose? Because it feels like, yes, you are sort of evolving the Ion spacecraft, right, and sort of using it, but is there going to be in the future like one in all solution, or is it just going to be, we do different types of spacecraft?
That's a very good question. It's a very good question because it's one of the trade-offs we currently do on our side. Like, as a my responsibility as business development, in the Orbit business development, to be very clear, it's not sales. We have a sales department. Business development, we basically take the input from the customers. We develop the service together with the tech and operational side. So we are more like a service development rather than a business development, if you strictly use the words. So what we do really, this is one of the trade-offs we do all the time. Now we are more oriented to have a family of spacecraft divided by size. So we will have the Ion, which will be smaller size in terms of delta V capabilities and payload capabilities. And then we'll have Gaia, which would be more on the larger payloads, larger capability, much larger delta V. And we'll try to be as cross orbits as possible for the moment. So we think that in future, the Ion class of spacecraft will be able to serve both LEO and GEO and lunar orbit, for instance. And same thing for Gaia. This is what it looks like the best option going through the trade-off. We may change our mind. I can see that clearly, but
Yeah.
but for the moment, I think we are pretty set for the next 3 to 4 years. I think we're pretty set on that way.
Yeah, I mean, it's fair, right? Sometimes if things change, you can eventually change your mind. Yeah. Do you see also, because we've seen a lot of other companies, right, that have also focused on space delivery or even have moved on from other sorts of applications, right, to space deliveries. Then they'd be like, you know what? Let's do our own sort of satellite bus as well, like just completely having your own satellite bus. Like, are you planning that sort of thing? Are you working on some kind of mission or program that might be sort of an application of the Ion spacecraft, for example?
Yes, we do. We do. We are working, for instance, on the NOx program. The NOx program is basically an Earth observation program on a spacecraft, which is heavily based on Ion. So, because like after the COVID crisis, there were a lot of resources in Europe given to member states, countries, the European Union to basically help industry to recover, right? So one of the missions we decided to do with those funds is this Earth observation mission. Earth observation is not really our expertise. So we wanted to do that because we said, okay, let's try to push the boundaries of our capability as much as we can. Let's try to push the Ion spacecraft as much as we can, and let's see how it goes. Let's see what we can achieve. Of course, it was not a blind exercise. We knew where we were going, so we partnered with a small company, but very capable, that does SAR instruments, so radar instruments. And we developed this 500 kilogram spacecraft, and which is, yes, exactly, that's part of the Iri constellation, which is the Earth observation constellation Italy is building for its own purposes. And it looks like it's a beautiful spacecraft. Now we are starting to actually build the flight model. We went through all the engineering and structural models, and it's planned for launch in, next year, so 1 year from now. And there was really an incredible exercise because it was really taking the Ion spacecraft, because if you see an ion as a very particular structure, right? It's a cylinder. It's not a cube. So we did like this because it's more efficient when you need to do some kind of missions. So, for instance, all the electronics is exposed outside. All the payload bay is exposed outside. And this is easier because, like, you can integrate or change modules until very late. We integrated some of the payloads really a couple of days before launch, and we changed it, let's say modules that were malfunctioning a few days before launch. And this is because everything was like outside the principal body of the spacecraft, and it's a little bit more efficient structurally. It's not that efficient in terms of space, so you actually don't occupy all the volume that you have. But it has, like for a space carrier, we think it's pretty efficient. So we tried also we kept the same sort of structure, the same sort of concept for doing this SAR spacecraft. It's coming up pretty original. So there are some pictures on the web that you can find to see our SAR spacecraft. And it's high resolution one, so big performance. And we can go lower than 1 meter resolution on ground. And so, yeah, that was really, really an incredible exercise. They were still doing it. And it's been a big challenge. The team working on NOx was super young team. And it was incredible to see how they could really prove their skills and capabilities. It was really, really exciting, to be honest.
Yeah, one of the other things as well that I'm really interested, because once those satellites are built and launched, they're gonna have to go in some rocket. I don't know if that's something that you guys are gonna be having to decide, or somebody else has to decide that. I'm not sure about that. Is that something that you guys can control?
The rockets where the ion goes, you mean?
Yeah. No, where
with the
this
NOx,
project for the NOx.
That's a good question.
If you cannot answer, it's okay.
No, I can answer, because yes, I mean we have one option, which is of course an European launcher, and then we have to consider a backup option, which of course is our partner SpaceX. So it's I mean, of course it would have been better to have just one launcher as baseline. But we're also quite used to design spacecraft for multiple launchers. So our Ion spacecraft is designed for multiple launchers, and so we're not that scared about that because we knew how to do it. Although, of course, if you have a launcher set since the day one of the mission, it's easier for the engineers, of course.
Yeah, I've also been wondering, because we had this question from the chat about larger rockets. So far, I mean, Falcon 9 is a decently sized rocket, I guess, right? It's not a small rocket, and the way that you guys go into orbit is, most of the time you go on transport missions. There were a few that went on Starlink missions. In general, you go as ride shares. But have you thought of like going on a smaller launcher, like a micro launcher, just as the payload, right? And now you have a bunch of things on the Ion spacecraft. Like, has that been a consideration as well?
Yes, absolutely. Again, really, I mean, part of our job, I mean, it's for the only thing we cannot cover in the value chain is launches. So for us, it's very important to collaborate and partner with as many launchers as we can. Of course, we have been considering micro launchers. We've been talking with them, and in some of them, actually most of them, Ion just doesn't fit. And some other of them, they provide similar services that Ion can provide. We are very, very opportunistic from that point of view. So like if it works, if it's compatible, if the price is within what our customer expects, we definitely have no problem to collaborate with micro launchers in order to make this happen. So we're definitely talking with them, also because some of them are also developing larger rockets. And yeah, so it's honestly, we are probably one of the few, the most interested parties in the world that wish the launchers industry to succeed quickly, to be competitive, and because definitely we need more competitive launchers out there.
All right. Yeah. So I'm gonna hand it over to Dee again. We have a few more questions from the chat, and now I'll go back to some of these missions that you guys have done. Dee?
Yeah, so there have been a couple more questions in the chat. First up, there's one from James wondering if these vehicles could be made reusable. And I would tack on to that, would there be value in being able to refuel them in orbit? You've already done like rendezvous type stuff, so
Yeah, we definitely plan to have our tags refueled. So GEA, the GEA spacecraft, is planned to will be designed to be refueled. And from a personal point of view, I think that the tug refueling market is the one among the refueling that makes more sense. Because maybe it's a little bit premature now, but we definitely see the advantage because we basically are paid by delta V. So the more delta V that we have, compatibly with of course, the lifetime of the electronics, the better it is. So yes, reusability through refueling our space tags absolutely is something we are looking at very carefully.
awesome. And next up, one we are used to seeing around here. They're wondering about any internship availabilities. They didn't see any on your website, but we have a lot of viewers here. This one, they are studying space engineering currently, but if you have any positions, things you're looking for, things that they should know about getting a career.
Actually, I'm surprised we don't advertise internship. I ask why, and I personally don't know. I'm surprised. Usually, I mean, like, yes, we are looking for the best and the brightest minds that could join the orbit. Absolutely, we have offices in Italy, where it's main headquarters, but we also are in Portugal, UK, and also the United States. We have recently have a subsidiary there. And so, yes, absolutely. Please feel free to reach out through our web forms and emails. And if you're looking for challenges and a very nice and Italian environment, if you come to Italy, that's the right place. Or if you want to stay in the US in Denver, Colorado, that's fine too.
All right. Thank you very much. I'll pass it right back over to Alex.
Yeah, that is very nice. The weather here as well is really nice.
Yeah.
I gotta say. One thing, you were mentioning that business development is not sales, but I do have a question about customers though. Like, it feels to me that you guys launch quite frequently. Like, you seem to have demand. Do you see that demand rising lately, or has it been declining, or like how do you see that in the future? Because it seems like it's getting more and more things going up in space now.
Yeah, demand has been rising. So what we have observed in this 4 years operations, 5 years operations, that the size of the spacecraft that we are carrying is increasing, and also it's increasing a lot the need for in-orbit the demonstration and validation. So that at the beginning, we had maybe just 1 or 2 experiments hosted payload on our spacecraft. Now it's almost half. And so, which is good because it means that the space economy is dynamic. There are more and more companies that need to test their technology in orbit, and that would eventually lead to a better supply chain, which is something that we will all benefit of. I mean, the reason why now we are developing almost vertically our spacecraft because the supply chain isn't that ready yet. Maybe in the United States is less of a problem, but Europe, we don't have such a wide supply chain that you can say, okay, I choose 1 or 2, 3 suppliers, so they're all equivalent, and so I can switch from one to the other almost seamlessly. We are getting to that point, or we're still not to that point. So yes, so the trends are definitely increasing number of customers that would increase a little bit the size of the spacecraft, and we see more and more hosted payload and experiments.
Yeah, I'm not. There's always been this thing. I'm not gonna ask you to reveal any secrets or anything, but has there been any weird requests or something like that for some of the customers? Like, I cannot think of anything, but like something like because it feels like with so many customers, right, and so many capabilities of the Ion spacecraft. And for example, we had the Starfish space other spacecraft, imaging and everything. Like, has there been any sort of weird thing going on there? Like, oh, okay, let's do
Okay.
this.
All right. So we had that in many weird requests. So like people that really wanted to transport to space everything, like everything you can imagine, like their belongings or like pictures or things like that. And I mean, some of them we made them happy, some of them no, because they were not unfortunately able to pay as much as we could ask them. But yeah, I
Yeah.
mean, we currently have, I mean, continuously have requests of people that want to bring them belongings somehow to space. Yes, we had some no weird requests, but like there's a lot of again, the space is very dynamic, so there are a lot of companies that have a lot of creativity, and so that's like we've been sending to space also belongings of people that are like they passed away or things like this. And there's a lot of creativity in space, so we've been at a lot of different requests, which I'm actually honestly very up to, because it means that really we can use space as an additional resource to our use. Of course, we need to use it sustainably. That's granted, of course. And but still, it means that people are starting to see space really as an extension of something that's within their reach, something they can actually access. And this, again, as a space enthusiast, is something that I'm really proud to contribute to.
Yeah, that's really exciting. I mean, and also in another sense, I guess, is that the weird request, if you can actually follow along and deliver on the promise, and it's like, we did that, right? We did the weird stuff, the impossible things, or stuff like that, right? I even was wondering, like, you have delivery services and logistics to space. Have you thought about things coming back from space, for example, capsules or things like that, or a delivery the other way around, I guess?
Yes. Okay, we are interested in that, but I mean that's not something we would like to develop. We are talking with a few partners developing capsules, and we are looking at the business model together with them. It's not obvious to close a business model like that, because developing a capsule, it's very hard, especially because you need to know where the capsule goes back with a reasonable certitude, which is not easy, both from the capsule point of view and the spacecraft point of view. So I don't see us developing a capsule in the next future. I definitely see us collaborating with some partners that does the kind of service and find a good business model that works and can get back things to customers on Earth. Absolutely.
Yeah, I guess, for example, like slapping one of these capsules on an ion, but the capsule is from somebody else, and then they can recover their own thing. And, you stay there, it's slapped to the side of an ion, and then it's like, okay, goodbye. And it sort of separates. Like, that will be an
Pretty much,
interesting application. Yeah.
Yes, absolutely.
I'm gonna go one last round here with DUIs and some of those questions from the chat, because I've seen some of them already rolling by, and then we go to the final round. I have a few final questions there.
Absolutely.
But D, what do we have from the public?
Yeah, so there were a couple people that were just wondering what your favorite mission has been and what you are most looking forward to.
Good question. Okay, there are many missions that are related with several payloads. I mean, one of the missions that I liked most was, I think, a CV4, because it was the first one. This time we had a real camera, like Earth observation camera. So I remember all the team. Yeah, I think it was Eleonora. All the team waiting for those images. I mean, we have small cameras on Ion, but like the very low resolution, very little bit, not really super clear. So we were waiting for those images so badly because I think it's so nice, so challenging to be able to send something to space to take picture back to space. It's like a gift when the spacecraft gives back to you, right? So I think that I remember that mission a lot as a very specific. I also love I like the SCV. I think it was 14 and 15 because it was our first double launch. So we launched 2 at the same time, and it was very challenging, and it was really demanding, and it was really looking forward to it. So the next mission definitely. Now I've been following a lot the Gaia mission, so the in-orbit servicing one. That's super challenging, and but I have to say that my favorite one is Nox. So because well, mostly because I think I can reveal this. The CEO of the other company that develops the SAR payload is a friend of mine. We did university together. We didn't see each other for like 10 years. Then we meet up again. We said, I don't know, why don't we put my payload on your spacecraft? I said, yeah, that looks like a good idea. And we started in 2017. And then, it became a mission. And it's a very challenging mission. And all the team is like hating me because it said, oh, that's so difficult. Why you guys conceive such a mission? No, I'm kidding. But there was it's would be really demanding, really challenging, and the team was incredible because we have a very strict time constraints on Nox. So you have to launch, we have to develop these things and be ready to launch by mid next year. So in like a super short time, a little bit more than 2 years to develop, to basically adapt Ion and to build a spacecraft for a mission that we never done. So I think that's currently my favorite, and I'm really, I wish I could give enough support to the team doing that, and I'm really looking forward to the launch next year.
Oh, that's super cool. I can't wait to see that. And with that, I'll hand it right back over to Alex.
Yeah, one of the things that I have sort of last here before we wrap up is, the context of where we are, right? We are in Europe, both of us, of course, and so this show is precisely about Europe's future in space. So I have always a question of like, how do you see deorbit within the market of you? Because I don't see a lot of European other companies, doing this sort of stuff, right? And so it feels like deorbit is unique in this sense in Europe, but also in sort of the global market, there are a few companies also trying to do that, but it seems like they're still getting there, right? Whereas deorbit is like we have 17 of these already launched, and so. What was that an advantage, a disadvantage? What do you think might need to change to get better, or if you think it's already good? Like, what are your thoughts in that sense? Like being here in Europe as a space delivery company or logistics company.
That's I mean that's a question that has multiple answers. Definitely. I mean, usually we compare space industry in Europe to the space industry in the United States. And of course, we have the sort of disadvantage that we are we are a continent divided in multiple states. And so when when you decide to allocate fundings or to have a common strategy, it's never easy, right? So for large projects, sometimes you need contribution from different countries. And also, as I told you before, the raising money in Europe is not as easy as could be in the United States. So these are definitely the disadvantages. And of course, I'm not. I wouldn't say that Europe has definitely a competitive advantages. I think Europe is still a very solid and healthy environment to do very high quality technology and services in space. I don't think we believe that hard enough. I don't think in Europe we. I don't think we are willing to risk that much in order to achieve very competitive things in space. We have been able to do incredible missions. I mean, I think about Rosetta, the mission that went to the asteroids, and I mean, we've done incredible things. Even the launchers, big. Okay, now we can discuss about forever that big Ariane 6 doll launch. As much as Falcon 9, but if you take Falcon 9 out of the picture, still, I mean, there's a lot of launcher company in Europe, and also it's very difficult in Europe to have a launch site, so we need to go up north in Scandinavia to launch, because it's not really easy to find a not densely populated area. So there's a lot of disadvantage from that point of view, but still the industry is very healthy, given the objective difficulties that we have. So the lack of funding and the European funds, the institutional funds, they are spread over countries. So sometimes I think the other way around. Imagine how competitive it would be Europe if we had the same situation that was in the United States. So like much larger fundings, much clearer policy. I'm sure that many Americans will disagree with me now. Okay, I invite them to come in Europe and see the situation here. And so I think really those difficulties, those objective difficulties, has made European space industry very resilient, and that's probably our competitive advantage.
Yeah, I've also referenced, the fact that you guys have launched 17 of these spacecraft, and there are upcoming other companies as well that are trying to get into the space logistics side of things, and maybe they're like on their second mission and things like that, but they're still struggling to get through and everything, or they have maybe even failed it and things like that. Whereas D-Orbit has had the advantage of already, like I feel that also has some kind of advantage as well of, hey, we're actually the real deal, right? Like you're delivering actually instead of still in development kind of thing. Well, that's definitely, if you have anything else that we may now have to talk about, I usually give this opportunity to our guests to sort of go through anything that you might want to say that I've not asked about. If you have anything to say, now is your moment, I guess.
Difficult people like this. No, it's no, definitely again, I'd like to stress how really how long was the Orbis journey in the space logistics, and really I'd like to stress in space industry this feeling of we are building something incredible, and we need everyone to succeed in order each one to succeed in his own. Of course, we'll be competing. Of course, the competition will be harsh, but still, I mean, there's a similitude that I love a lot, and our CTO uses that most of the time. It's like, there was in past history, there was a generation in like where the fish learn how to actually walk on the ground, on the solid ground, right? And there was the generation where like the life on Earth, on actual Earth, was born, because before life was just on the ocean. And we are that generation that actually are learning how to live beyond our atmosphere in space. So we are in a very privileged position. Our generations will be remembered forever in history as that generation that made possible to live beyond Earth and be actually a galactic mankind. And so I really encourage everyone, when you talk about space industry, yes, of course, it's an industry. Yes, of course, we need to follow the market laws. Yes, we need to compete. Yes, we need to generate values in order to pay back our investors and to pay the salaries to our employees. But we also have I wouldn't say a mission, but we also have a sort of responsibility, right? To use this natural resource, which is space, in a sustainable way, in order that us, as first generations of people that are learning how to live in space, will pass this message to the following generation afterwards. I think this is very important. And I think that's also something that motivates us and motivates my colleagues every day to do well their job.
That's awesome. Very, very, very inspiring as well, right? That, everybody doing better, it's better for everybody, in that sense. Thank you for being here, Stefano. And,
Thank you, Alex.
lots of luck to the orbit in all of the upcoming missions. I'm gonna keep track of those with those transporters, and hopefully in the future as well with PLD Space, Spanish launch company as well. And
Absolutely.
and also thanks to DYs as well for all the questions from the chat.
Thank you, DY.
Of course.
And also thanks to our viewers and also our members. We have, of course, our membership program here on YouTube. We have launch directors as well and flight engineers right at the top of those tiers of all of the membership programs. You can see the names are like super tiny already. So many people. These are the highest tiers of support. Really thankful for that. We couldn't be doing all of that we do without your support. And of course, we have Jay Keegan in the background as well, pulling all the levers and pushing all the buttons. He's also arranging a lot of future interviews with lots of different companies. If the company that you're thinking about, European company, you're like, I want it in the show, don't worry, we're probably asking them about this and everything and trying to arrange interviews. Just takes time, right? And so, but we'll get them here whenever possible. And thanks again to the Orbit and Stefan as well for coming to the show. And of course, until the next one, see you later.
Thank you, guys.
And here we go.
We have liftoff.
Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, roll, planet.
Water towers, fly! Yes!
They go down to nominal.
Flight downside speed off. Bring in SPD off.
It's orange! 125! Oh my god! Oh my god!
Décollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You read? Sure. We don't need any more of these.